Good evening, all. Students, kindly inform your friends to join the session. We'll wait for 3 to 4 minutes more. I request please inform your friends to join the session as soon as possible.
Smita, are you able to hear me?
Yeah, good evening, sir. You're audible.
Yeah, okay. So shall I start the session or do we wait?
I think we can start, sir.
Okay, okay.
Yeah, as I told sir, today we are conducting the assessment, which is day 15. So till 8:15 you can take a class. After 8:15 I'll be sharing assessment link on the same chat. They can take assessment. Till 8:15 you can take a class, sir.
Okay, okay.
Yeah.
Friends, give me a 1 minute. I will start it up. So my clips got stuck. I'm restarting it. Okay. Good evening, students. Sorry, I had to restart the system because my system got stuck actually. Sorry for waiting you for a long. Okay. So I see good amount of strength today. Okay. Good evening, Jeanette. Good evening, Aryan. Good evening, Mamata. Good evening, Aryan. Good evening, Kajal. Good evening, Shravanti. Good evening, Sandhya. Good evening, Suyash. Good evening, Satyam. Good evening, Vinit. Good evening, Rani. Good evening, Sandhya. Good evening, Mambia. Yeah. So they are excited for assessment as well, Suyash. So because of that, I guess. Okay. So okay. So what is discussed in the last class where we have stopped? So as informed, we will be continuing the session until 8:15. Okay. So what is discussed in the last class? We went with the trees, right? We went with the trees and then trees and BST, right? We have completed the trees part and BST part. Okay, here we have seen the traversals, and then here we have seen now the BST, like binary search tree, right? Then in traversals, we have discussed about pre-order, post-order, and then in order as well. And in binary search tree, okay, we have discussed how to insert a node into binary search tree as well, right? I asked you to do the deletion. I asked you to do the deletion. And here we have also seen two lead code problems like identical trees, and we went with symmetric tree. I have explained the intuition. So I asked you to do. Is it done, guys? This lead code problem is done. Yes, this lead code problem is done. Good evening, Sangam. Good evening, Sai. Good evening, Sneha. Is a symmetric tree lead code problem is done? Yes. Are you facing any issue here? Deleting a node from binary search tree. Okay. So yesterday we discussed all about the trees. Okay. Today I'll be going with the graph. I will be discussing the graph traversals as well. So let's start the new data structure, that is nonlinear data structure, that is graph. Okay. So what is a graph? What is a graph? So graphs are basically divided into two types. Okay, directed graph, and then you have the undirected graph. Okay, directed graph, and you have the undirected graph, and also you have the weighted graph also. Weighted graph also. Okay, weighted graph also. Okay, good evening, Anurag. Okay, we have the directed graph, we have the undirected graph, and then we have the weighted graph also. So basically, graph, how you will be doing, you will have your nodes, the same nodes again. Okay, but these are connected together. Okay, these are connected together through edges. Okay, these are connected together to edges. Okay, ignore the drawing. These are connected through. These are connected through edges. Okay, so 1, 2, 3, 4. So this is another, this is one of the graph. Okay, so here these nodes what were there, like this so this is also one of the graph, right? So basically these nodes what were there, what you are writing, those are called, also called as vertices. So you have the vertices of your square, right? Like the square, this is a square, right? So you have the vertices for your square. So these are also called as your vertices. And what these nodes are connected by one link, right? That link I can call that as edge. I can call that as edge. So graph will have vertices as well as edges. Okay, as well as edges. Okay, so these nodes are also called as vertices, and these nodes are connected through edges. Okay, And if you can see here, I can move from 1 to 2. Okay, I can move from 1 to 2. I can also move back also, because this is a undirected graph. So I can go in bi-direction. Okay, I can go in both the directions. Here also I can go. Here also I can traverse. Here also I can traverse. If you are concentrating on the traversing part from one vertices to another vertices, if you are doing the traversing part, then I can move in forward direction also. You can move in reverse direction also, since it is a undirected graph. Okay, so if you can see 2 comma 3, there is edge is there. Okay, then 3 comma 2, there is an edge is there. And 3 comma 4, there is an edge is there. Then 4 comma 3, there is an edge is there. 1 comma 4, there is an edge is there. 4 comma 1, there is an edge is there. So like this, all the edges were there. So many edges were there. 1, 2, 3, 4, 5, 6, 7, 8. 8 edges were there. 8 edges were there. So basically I can move forward also, I can move backward also. So because of that reason, this is called as undirected graph. This is called as undirected graph. Undirected graph. Okay, so because of that reason, this is called as undirected graph. Okay, and if you see this one, suppose A, B, C, D, E. So here I can move. So what are the things? So I can move from A to B. Can I move from B to A? Is it possible? Can I move from B to A? Is it possible? No, it is not possible, right? Then can I move from B to A? It is not possible. Only A to B is possible, and B to C is possible, whereas C to B is not possible, right? Only B to C, B to C, and C to D. Okay, and D to E, D to E, and E to A. E to A. E to A is possible, but A to E is not possible. A to E is not possible. Means this is a undirected graph. Only in unidirection you can go. Only in one direction you can traverse this graph. You can traverse this graph in only one direction. Only one direction. Okay, one direction. So this is called as a directed graph. This is called as a directed graph. Okay. Good evening, Pawan. So this is called as a directed graph, whereas this is called as a undirected graph. In undirected graph, you can move bidirectional. You can move bidirectional. Are we clear until this point? Yes, everyone. Are we clear until this point? Yes. Okay. So this is a undirected graph, whereas this is a directed graph. And in undirected graph, in undirected graph, in undirected graph, we will be like we can calculate the edges as well. How many edges will be there between each between each vertices? Okay, between each vertices, we can also calculate. We can also calculate how many edges can be there. Okay, how many edges can be there? Okay, so there is one formula like 2 into E in undirected graph. Okay, in undirected graph, 2 into number of nodes, basically number of nodes. Okay, 2 into number of nodes or number of vertices. Okay, how many are there? That you can go with this formula and you can measure the number of edges. Okay, number of edges. So basically, what is there here? How many nodes were there? 4 nodes were there. So total vertices were 8. Total edges were 8. Okay, total edges were 8. So 1 to 2 you can go, 2 to 1 you can go, 2 to 3 you can go, 3 to 1. So there are like 8 edges here. Okay, 8 paths. I can also call it as paths or edges. So basically edges. Okay, so this is how you can calculate. So what is the formula here? Number of edges in an undirected graph is 2 into number of nodes or vertices. So they'll ask in the interview how to calculate the number of edges. Okay, number of edges is equal to 2 into number of nodes or vertices. Are we clear until this point? Are we clear until this point? Yes, everyone? Yeah. So again, now suppose I am constructing a 5 year. Okay. So means every node will have two edges, right? Every node will have two edges and you can move forward and backward. So because of that reason, it will have eight edges. Okay. It will have eight edges. Now I'm drawing another vertex. I'm drawing another vertex. Okay. I'm drawing another vertex and there are two edges here. There are like two edges here and this is the fifth node. So how many edges have now? How many edges now? 2 into 5, which is nothing but 10 edges will be there now. Right? 1, 2, 3, 4, 5. 5 nodes, right? 10 edges will be there, right? 1, 9, 2, 4, 5, 6, 7, 8. Okay. So here if you see, this is also called as the, this is also called as the, so every node will have two edges, right? 1, 2, 3, 4, then 5, 6, 7, 8. And then 9, 10. This one also 9, 10. Right? So every node is two edges. So basically 1 and 2, 3 and 4, then 5 and 6, 7 and 8. Right? So I can like another thing, like we have a cyclic graph, we have a acyclic graph. Okay. We have a cyclic graph, we have a acyclic graph. Cyclic graph in the sense, suppose if you are starting here, if you are starting here and you are moving. So you're moving here, you're moving here, and then you're moving here, you're moving here, and again you're reaching the same node where you have started. So that is called as a cyclic graph. Okay, that is called as a cyclic graph. I can also call that as closed path. Okay, so in a cyclic graph, it is a closed path. So basically, when you are starting from here, you are reaching the same node again. When you are starting from here, again you are again reaching the same node. Okay, where you are starting, that node you are reaching it up. So that is called as your cyclic graph. Okay, that is called as your cyclic graph. Okay, so a cyclic graph in the sense which will not have any cycle. So basically, if you can see, suppose I'm drawing like this. So this is called as your acyclic graph. So I can move here, I can move here, I can move from here. So this is called as your acyclic graph. Are we clear until this point? Are we clear until this point? Can I call this as your cyclic only? This also has cyclic. This is also like cyclic. Can I call this as also cyclic? Yes, this is also a cyclic because you're moving. If you're starting at A, you're reaching again A, right? You're again reaching that particular node. That particular node, you're again reaching that particular node, right? So this is called as a cyclic. Suppose it is there like this. This is like this. Okay, this is not there in the front. It is there like this. And okay, so now you see, I'm starting from here. I'm starting from here. So if I'm starting from here, you see, I can only move from B to A, but I cannot move again to B here. Yes, this is a acyclic graph. This is a acyclic graph. Are we clear? So cyclic in the sense from where we have started, if they are reaching node, each and every node, if I'm able to reach again. Okay, that is called as a cyclic graph. Whereas if I'm not able to reach, that is called as a acyclic graph. Okay. So these are the types of graphs that were there. Okay, these are the types of graphs that were there. And so this is how the graph terminology as well, vertices and edges, and you have the undirected graph, you have the directed graph. Whereas undirected graph is unidirectional or like bidirectional. Okay, it is bidirectional, whereas directed graph is only one direction you can traverse. It is unidirectional. And you have the cyclic graph, you have the acyclic graph. Okay, so this is the graph terminology. Okay, now Now, can I call this as a graph? Can I call this as a graph? Can I call this as a graph? Yes or no? Yes or no? We are calling this generally as tree, right? We are calling this generally as tree. But this also has nodes. This also has nodes, right? This also has vertices. Can I call this as edges? Edges between the vertices. Yes, they are connected. So I can call the tree also as graph. I can call the tree as also as graph itself, right? Suppose. Can I call this everything as graph? This everything as graph. Suppose the thing is like this. Okay. So okay, 1, 2, 3, 4, 5, 6. 4, 5, 6. Okay. Can I call this as a graph? This whole thing, can I call this as graph? Yes or no? So if you can see now, if you can see now, 1 and 2. 1 and 2, there is an edge is there. And 2 and 1, there is an edge is there. 1 and 3, there is an edge is there. 3 and 1, there is an edge is there. And then you can move to, immediately you can move to the 4 also. Right? You can traverse the path you can construct, because after 3, there is only 4 is there. Right? Fourth vertex is there. So you can traverse, still you can traverse. So 5 and 4. And then you are traversing to the sixth node. You're traversing to the sixth node. So suppose if I'm traversing, I'm starting from here. I'm starting from here. And then I'm traversing to 2. I'm traversing to 2. Then again I'm going back. I'm traversing to 3. I'm traversing to 3. Then using a loop, I'm moving to the fourth node. Then again I'm traversing to fifth node. Okay. Then again I'm traversing to the sixth node as well. Okay. So since it is like continuous it is there. So connected. So like continuously they were there. The nodes were there. So if they are not connected directly also, but the data is connected here. Data is connected here. So these types of graphs I can call that as connected components. Okay, connected components. Okay, I can also call this as connected graph. Okay, because the data is able to connect, the data is about to connect. So if it has one node also, I can call that as a graph. Are we clear? Are we clear? Yes. Okay. So now going to the next topic, that is graph traversals. Graph traversals. Okay. So how to traverse the graph? In everywhere we have seen this, right? In every data structure, after discussing the terminology, we went with the traversal itself, like how to move from one node to another node. In linked list also we have seen. In stack also how to insert, how to delete operations we have seen, right? And and in queue also we have seen, and then in tree also we have seen, and now we are going with the graph as well. Okay, in graph as well. So so what is a traversal over there? What is the traversal? Like how many traversals were there is? There are like two traversals. Traversal in the sense moving from one node to another, right? Moving from one node to another, or moving from one vertex to another vertex to the edge, right? We have the BFS, which is nothing but breadth first search. Okay, breadth first search. Okay, breadth first search. Then we have the DFS, which is depth first search. Okay, depth first and then search. Okay, whereas breadth first search is also called as level order traversal. Okay, level order traversal. Whereas depth first search, I can call this as height. Okay, height from where, from one node to another node, I will measure it based on the height. Okay, so how to perform BFS over your graph, how to perform DFS over your graph, and how you can traverse. Let me draw on one graph. Hmm. Okay, I'm drawing a uh, okay, 1, 2, 3. Before this, I wanted to explain how you represent the graph. Okay, how you represent the graph. So before traversal, I want to explain this, how you represent the graph. So how you represent the graph means there are like two ways you can represent the graph. One is adjacency matrix. Okay, adjacency matrix. One is adjacency list. Okay, adjacency list. Adjacency list. Okay, so if you can see this, it is a one based graph. It is a one based graph. Okay, it is an undirected graph, and this is a one based graph. I can also call it, because it's starting from one, so I can call it as one based graph, right? So in adjacency matrix, how you will represent this means, like if you wanted to represent it, if you wanted to represent it, so basically you will draw a matrix in the sense you will have your rows and columns, right? You will have the rows and columns. N plus one matrix you will be drawing. Okay, n plus one. N plus one rows, n plus one columns. Okay, how many nodes were there? One, two, 3, 4, 5, 6 nodes were there. Right? So you'll be drawing a 7 rows. Okay, 7 rows. 1, 2, 3, 4, 5, and then 6, and then 7. Okay, you will be drawing a 7 rows, and then you will be drawing a 7 columns as well. Okay, 7 columns. 1, 2, 3, and then 4, and then 5, and then 6. Okay, so you'll be drawing like this, and then this is your 0, and then 1, and then 2, and then 3, and then 4, and then 5, and then 6. Okay, then here also 0, 1, 2, 3. So this is the default format we'll follow. Okay, 0, 2, 4, 5, 6. Okay, now 1, then so there is edge from 1 to 2. There is edge from 1 to 2. So what you will do, just you will put it as 1 to 2. There is an edge is there. Okay, there is an edge is there, and there is an edge from 2 to 1 as well. 2 to 1 also there is an edge is there. Okay, say 2 node and then 1. Okay, 1 to 2 there is an edge is there. 2 to 1 there is an edge is there. And how many next one is 2 to 3 there is an edge is there. 3 to 2 also one edge is there. Then 3 to 4 one edge is there. 4 to 3 also one edge is there. Okay, then 5 to 6 you have edge, and 6 to 5 also you have edge. So 1 to 2, 2 to 1, and then 2 to 3, 2 to 3, 3 to 2. Okay, 3 to 2, and then 3 to 4, 3 to 4, and then 4 to 3. Where there is edge, you are putting 1 if you are observing. 4 to 3. Okay, and then 5 to 6, 5 to 6, and then 6 to 5, 6 to 5, there is an edges. Where there is no edge, you will make it as 0. You will make it as zeros. Okay, where there is an edge, you will make it as 1, 1, 1. Where there is no edge, you will make it as all the things as 0 apart from that. Are we clear? Are we clear? Yes. Are we clear? So this is how you do the adjacency matrix. Adjacency matrix. But what is the space complexity of this? Space complexity of this adjacency matrix and time complexity. So space complexity will be big O of n plus 1 into n plus 1, right? N plus 1 into n plus 1. N plus 1 rows and n plus 1 columns. So it will be basically n square, right? Whereas time complexity, one loop is for rows, another loop is for columns, right? So again it is n plus 1 into n plus 1, which is n square itself, right? So this will be the time and space complexity. That is a disadvantage with this like space complexity you're occupying. So that is a disadvantage with the, that is a disadvantage with your okay, disadvantage with your graph, with your adjacency matrix. Whereas if you go with the adjacency list, you can also mention this adjacency list. Okay, what you will be taking, you will be taking an n plus 1 array. Okay, you will be taking an n plus 1 array. So 1, 2, 3, 4, 5, 6. Okay, I'm taking 7. Okay, 0, 1, 2, 3, 4, 5, 6, 7. Okay, now 1, in 1 you will be placing, in 1 you will be placing, in 1 you will be placing 2, right? In 1 you will be placing 2, and in 2 you will be placing 1. You will be placing 1, and in 2 again you will be placing 3 as well. Adjacency list. Okay, internal you will take the list again. Okay, internal you will take the list, you will place the 1 and 3. Okay, 1 and 3, 2 through and 3 to 2, 3 to 2, and then 3 to 4, 3 to 4 is also there, right? 3 to 4, and then 4 to 3. Okay, then 5 to 6, 6 to 5. Okay, 5 to 6, 6 to 5. This is wrong. 5 to 6, 6 to 5, and then where I am missing it? Am I missing anything? 1 to 3, 2 to 1, 1 to 2, and then 2 to 1, and then 2 to 3. 2 to 3 is also edges there. 3 to 2 also edges there. 3 to 4 also edges there. 4 to 3 also edges there. Okay, 4 to 3 also edges there. 5 to 6 also edges there, and then 6 to 5 also edges there. Okay, like this you will represent in the adjacency list. You will take an array, you will take a list. Okay, then you will again internally you will take the list. So what you are doing here, so basically I will explain it here. So you have the 1, and then 2, and then 3, and then 4, and then 5, and then 6, right? You have the 1, you have 2, and 0. Okay, so now what you will do, like 1, 2, you will take a list for each and everything. Okay, you will take a list, adjacency list. So 1 to 2, there is an edge is there, so you'll be representing 2 here. Okay, then 2 to 1, there is an edge is there, you will be keeping that here. Okay, then 1 to 6, there is an edge is there. Okay, 1 to 6, there is an edge is there, and 6, and 6 to 1, there is an edge is there. Okay, 6 to 1, there is an edge is there, and 6 to 5, there is an edge is there. Okay, 6 to 5, there is an edge is there. Then 4 to 3, there is an edge is there. 3 to 4, there is an edge is there. Okay, there is an edge is there, and 1 to 6, 6 to 1, 1 to 2, 2 to 1, and 6 to 5, 6 to 5 is done, 6 to 5 is done. 5 to 6, there is an edge is there. Okay, then 5 to 4, 5 to 4 also there is an edge is there. 4 to 5 also there is an edge is there. Okay, 4 to 5 also there is an edge is there. 3 to 4, there is an edge is there. 4 to 3 also edge is there. Okay, then 3 to 2, 3 to 2, there is an edge is there, and then 2 to 3, there is an edge is there. So like this we will draw the, we will draw the okay, we will draw the, we'll draw your adjacency list. Okay, adjacency list. Are we clear until this point? Are we clear until this point? Yes. So what is the time complexity of this? What is the time complexity of this? Space complexity. Okay. So one loop for traversing, one loop for traversing, one loop for traversing until 6, right? Until 6, one loop for traversing, right? And then I'm just adding it to the list. I'm adding at that particular index. I'm taking at that particular index, right? So the time complexity will be big of n itself. Okay, we go of n itself. Okay, directly I will add it up within that particular array at that particular index. Okay, and then space complexity will be for storing your array, which is big of n. For storing your array, big of n. Again, internally you are storing, like here internally you're storing another list. In the worst case, this list can contain all the things. Okay, so in this case, we can get the big of n. So we can take it as big of n itself. Okay. So list, you will use array list. Why you need a loop here? You are using like this. Okay. So basically you will take an array. Okay, you can directly take a array list. Okay, you can take an array list, and internally you will again use the array list if you want. Internally you are again using the array list. So what you are doing, you are just traversing over your nodes. You are just traversing over your nodes, and just you are doing array list dot add of. You are doing the and again you are adding the array list, the new array list. Okay, the new array list dot add of new array list of that particular value. Okay, at that particular index you will be adding at that particular index. So what you will do, uh, so you will get that particular list and then you will add it up. Okay, so at that particular index only will add it up. So you need only one loop there. You need only one loop there. So big of n. Okay, so this will be the how you will represent. So which is efficient now? Which is efficient in terms of time complexity? This one is efficient in space complexity also. This one is efficient. Okay, in the like big O of n. Okay, rather than your adjacency matrix. Okay, rather than the adjacency matrix. Okay, so going to the traversal part, we'll go with the BFS. So what I will do, I will drop everything this and you will write it up here itself. Yeah, for list you will be using a loop. For traversing over your nodes, you will use a loop. Okay, you will use a loop and then you will add it up. Okay, so for BFS part, for BFS part, you require for BFS part you require, so BFS in the sense I can move, like if I'm starting from one node. Okay, if I'm starting from one node, I need to move level wise. I need to move level wise. So if you can see, this is your first level. This is your first level. Either I can move this direction or I can move this direction, right? So what I will do first, I will move in the one. I will move from one, and then I will move to six. Then again I will backtrack. I will move to two. I will move to the two. Okay. Again I will backtrack. I will move to the two, and then again I will again like I will move from again then third level, then third level. So either I can move from 1 to 2 to 3. Okay, I will move 3, and then again I will backtrack. Again I will backtrack. I will move to 6 and 5. Okay, I will move to the 5. Okay, then what is left? Again this is 4. So like this I will do the traversal. I will do the traversal. Okay, level wise traversal I'll be doing. So for doing the level wise traversal, we need I will be taking a queue as a temporary queue. I will be taking. Okay, then I'll be taking the answer list as well. Okay, answer list. Okay, result list for storing this. Okay, then I need a adjacency matrix as well. Adjacency adjacency list as well. This list is also needed for me. Okay, I will check, like through this only I will traverse through this only. Okay, so what I will do, I will take a n plus 1 queue. Okay, n+1 size queue. Okay, of 7 size. 1 2 3 4 5 6 and 7. Okay, like I will take a answer queue as well. Okay, I will take a answer list as well. You can take it as a list also. Okay, you can take a list as well. Okay, so I'm taking a list. I'm taking a list. Okay, again I need a adjacency list as well for calculating your edges, for seeing your edges. Okay, so first what is there? First what is there? One is there. Okay, I'll be adding it in the queue. I'll be adding it in the queue. Okay, then for this, what were the adjacency elements, the neighbors? Okay, what were their neighbors? 2 and 6. Okay, 2 and 6. So what I will do, I will pop this element. I will pop up this element and then I will put the 2 and 6. Okay. When I'm popping it up, I will put the answer for this. Okay. I will put it in the answer array. Okay. Then for 2, I will go to the 2. I will go to the 2. What were the adjacents over there? 1 is there, but 1 is already there in answer array. I will not put it inside the queue. I will not put it inside the queue. What I'll be putting? 1 is already there. So what I'll be putting? Only 3 I will be keeping it up. 3 I will be keeping it up. I will pop up 2. I will pop up 2. Okay. And then what is there next? What is there next? 6. For 6, what were the adjacent elements? What were the adjacent elements? 1 and 5. So 1 is already done. So I will be putting the 5 here. I will be putting the 5 here. I will pop up I will pop up 6. Okay, I will pop up 6. So it will be 6. And the next one is 3. For 3, what were the adjacent elements? What were the adjacent elements? 4 and 2. 2 is 2 is already done, but 4 is not done. I'll be putting inside the queue. Okay, 4 I will be putting inside the queue. Okay, 4 I will be putting inside the queue, and I will delete the 3. Okay, I will delete the 3. Okay, then 5. 5, what are the adjacent elements? It is 5 and 4. It is 5 and 4. Okay, 4 is already there in the queue. 4 is already there in the queue. I will also check whether it is there in the queue also. Okay, so for 5, how it is again 5 here. For 5, what are the adjacent elements? 5 to 4. Okay, 5 to 4 and 5 to 6 right here. It is 6. 6 and 4, right? And 6 to 5. 6 to 5 here. Okay, so it is 6 there. Okay, then what I will do? 5. 5, what are the adjacent elements? It is 6. 6 is already there in the queue. 6 is already there in the answer. And also 4 is also already there in the queue. So I will just delete this. I will put it up inside the 5. Okay. Then what I will do? Then I will go with the 4. 4, what are the adjacent elements? 3 and 5. 3 is already done. 5 is already done. 3 is already done. 5 is already done. So I will pop this up of the queue and I'll be putting the 4 here. Now you see the queue is empty. The queue is empty and you got the same order here. Like 1, 2, 6. Here it is 1, 6, 2 I have traversed. Here it is 1, 2, 6, 3, 5 and 4. Either it can be 1, 6, 2, either it can be 1, 2, 6 as well.
It's
Okay, if
8
I'm
o'clock.
writing here 6 comma 2, if I'm writing here 6 comma 2, it will be 2 comma 6. It will be 1, 6, 2. If I'm writing 2 comma 6, then it will be 1, 2, 6. Okay, based on the adjacency list, how you are adding the elements. Okay, so this is how you will use a queue. You will use a adjacency list. Okay, you will use a adjacency list. Okay, and then you will use a answer queue as well. Are we clear? Yes, are we clear? Yes, everyone, are we clear? So this is how you will determine this. Like I have explained that only, right, Anurag? You are again asking me how we determine the sequencer. Anurag is full of doubts only. Like he will listen with previous knowledge. Like he will listen with predefined knowledge, what is there in his mind, and then he will start keeping on asking. But he will not listen to the concept what is taught in the current. Please listen first and then ask the questions if you're not understanding. So when you're not listening and when you are like when you're keeping on asking the questions and you're not listening, you're concentrating on the chat in that case. So in that case, you will miss the concept. Okay. Okay. So, okay, I will go to the code directly. I will go to the I will go to the code directly. Okay. So if you can see here, uh, I'm taking an array list, okay, for your adjacency list. I'm taking an array list, and then what I am doing, I'm adding all the edges. Okay, I'm adding all the array. I'm adding the list for all the edges. So 1 to 6. I've added the list, and then what I am doing, I'm adding the adjacency list, and then I'm adding the adjacency list elements as well. Okay, so like this, I'm writing an adjacency list like this. I will add up the elements. Get to u, add v, get to v, and then add u. Okay, so adjacency dot list, I'm passing the adjacency list here. So what will happen? So if I'm passing 1 and 2, what will happen? In the list, it will be adding as 1, 2, and in 2, you will add 1. Like this, I'm adding it up here. Okay, like this, I'm adding it up here. Okay, so what I am doing, 1 and 2, I'm passing it to the add edge. So what you will do? So in the list, what will happen now? So you will have the list. Okay, you will have the list until 6. Okay, until 0 to 6. Until 0 to 6, you will have the list 0, 2, 3, 4, 5, 6. Okay, and then for this you have the list already added here. Okay, in this code, the list is already added for all the things. Okay, then what you are doing? Then what you are doing? You are adding the edge as well. For everything, you are adding the edges as well. Now you are adding the edges using this. Okay, so you're passing the adjacency list and you're passing the 1 and 2. So what will happen now? For 1, so get of 1, this one. Okay, this list will be getting, and then add. I've explained this only, Anurag, like while you have asked the time complexity, right? So adding, I will not use a loop here. Directly I will get that particular index. I'll get that particular index, and then I will add up the 1 year. Okay, I will add up the 1 year. I will add up the 2 year, basically. I will add up the 2 year. Okay. I will add up the 2 year. Okay. So what I'm passing here, the u and v. So for 1, I will add up 2, and for v is nothing but 2, right? V is nothing but 2. For get of 2 dot add of 1. Like this, I will keep on adding for all the 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, and 5. So until for all those, I will add up those things. I will add up those things, and then what I am doing here. So the main logic is nothing depends upon your BFS. So I will pass the adjacency list to your BFS. To your BFS, I will pass the adjacency list, and if you can see here, if you can see here in the BFS, I am checking. I am checking. Like again, I'm taking a loop. I'm taking a visited array. Okay, I'm taking a visited array. Okay, of boolean. Okay, visited array of boolean, and then I am taking a array list as well. Okay, array list as well, and then I am checking if it is not visited. Okay, so what I am doing is nothing but this will be okay. First I will explain this. So this is for unconnected graphs actually. So single connected graph. Okay, this is single. What I am explaining. So I'm taking a queue. Okay, I'm taking a queue, and what I am telling, I'm telling it as true. So basically, visited of. I'm taking an array as well, visited array. So I'm just checking. I'm just checking whether I'm taking a boolean array. Okay, then I'm putting a true there. When it is visited, I'm taking a true there. So basically, to make me clear whether it is visited or not, to check. So initially I'm taking all the things. So 1 2 3 4 5 1 2 3 4 5. So initially this all will be false. So when the particular node is visited, I'm making this as true. I'm making this as true. Okay, so this node will be again will not be visited, again will not be backtracked. Okay, again will not be backtracked. So for that reason, I'm making this as true here. Okay, then I'm adding it to the source. I'm adding it to your I'm adding it to your source. When it is visited, I'm making it as true, and then I'm adding it to the queue. I'm adding it to the queue, and when it is not empty, when it is not empty, I am taking out the element what is there in the queue. One is added, right? That one I'm taking it up, and then I am adding it to the result as well. I'm adding it to the result as well, and then what I am doing, I'm adding the adjacent elements into the queue. Okay, if 2 and 3 are not visited, if suppose 2 and 3 are adjacent to 1, if they are not visited, then what I am doing, I'm making the 2 and 3 as true. Okay, 2 and 3 as true, and then I'm adding it to the queue. Okay, so this boolean array just I am taking to check whether it is visited or not, so that it will not like we will not go to that node again. We will not go to that node again. Okay, so for that reason I'm taking this as true, and then I'm adding it to the queue again. Then again same, when until the queue is empty, it will follow the same thing. Again it will poll the current element. Okay, it will poll the current element, what is there on the top, what is there in the front, it will pop that, and will add it to the result array. It will add it to the result array, and then again adjacency, I will be getting the adjacent elements of that, and then if it is not visited, I'll make that as 2. Again I will add it up into the queue. Again I will add it up into the queue. Are we clear? Yes, so this is how we will do it for the connected graph. We'll do it for the connected graph. Okay, this is how we'll do it for the connected graph. If suppose unconnected graph they have given, unconnected graph also they have given. If you wanted to do the BFS for that as well. So what you will do first, you will get the size. Why you will get the size? Because 1 2 3 they will give in the connected, in the sense they will be connected like this. So 3 4 and then 5, like this they will be connected. Okay, they will be connected through data. Okay, so for that reason you will again take a visited array from 1 to 5, 1 to 5, and then you will be taking a result array, and then if it is not visited, you will do the same thing again. You will do the same thing for connected graph also. So you will visit first one, and then you will add it to the queue. You will add it to the queue, the same BFS order you will follow, but you will check like this. You will use a loop and you will check like this, because you cannot go like this, that in the adjacency matrix it will not be there. So you will not be checking adjacency list for connected, for non-connected graph. Okay, for disconnected graph you will not check the adjacency list. Okay, for disconnected graph you will not check the adjacency list, whereas for connected graph you need the adjacency list. Okay, you'll only concentrate on the loop. You will only concentrate on the visited array. Are we clear? Are we clear, everyone? Are we clear, everyone? Okay. So I've explained the code here. Okay. Since the time is very less today, so I've copied the code and then I've explained it here. Okay. If it is not still understandable, it will be there in the notes. You can try run this. You can try run this. Okay. I'm giving it for you to try run. Okay, and you can let us know if there are any issues. Okay. Okay, I'll be sharing this code in the chat. Sharing. Okay, I've shared this code in the chat. You can try it afterwards. Okay, now I will move to the BFS. Okay, I will go to the DFS. Okay, so in the case of your DFS, in the case of your DFS, and one more thing in BFS, you need not to start from again one only. Okay, you need not to start always from one only. You can start from two also. You can start from the starting node can be two also. So in this case, what will be there? In this case, what will be there? This will be the level one for it, level two for it, right? Level one for it, level one for it, and this will be the, like if you can see, this will be the level 2, this will be the level 3 in that case. Okay, so if you're traversing, either you can traverse to 1, either you can traverse to 3. Okay, and then 1 to 6, 1 to 6, this will be the level 2, right? Level 2. And then it will be moving forward, right? It will be moving forward. This is the level 3, level 4, like this it will go on. It will move on. Okay, you can start from any end, you can start from any end. Okay, so clear all drawings. We'll continue this. Yeah, any node you can start first. Okay. So then I will be, so time is up already. Okay. For DFS, how you should be traversing. Suppose the thing is like this. Okay. Suppose this nodes is there. I'm taking a small graph. Okay. I'm taking this graph. So now you see, now you see, now you see. Like I'm starting from 1, I'm starting from 1, so I can go to 2, I can go to 2, or I can go to 4. So I will go to 2, I will go to 2, and from here I will not backtrack. I will go to 3 as well, because there is a connected edges here. I will go to 3 as well. Okay, I will go to 3 as well. Okay, then I will backtrack. then i will then I will backtrack. Suppose this is a direct, then I will backtrack. Then I will move to the 1, 4. Then I will move to 5 from here. Otherwise, I can go to 3 also, right? I can go to 3 also, but 3 is already covered. So 5 I will be moving. So like this means, if you can see, I'm going to the depth. If I can see, I will take it as like this. You will understand. Okay. So now what I will do, like if it is A, B, C, D, E, F, G. Okay. So now I can go to A from, if I'm starting from here. If I'm starting from here, I can go to G also. I can go to B also. So what I will do, I can go to B. Okay. Then I will move forward. I will move forward to this edge. Okay. It is C. Okay. Now nothing is there. So what I will do, I will backtrack. I will backtrack. I will move to D as well. I will move to D as well. I will move to E as well. Depth. So I'm moving depth. I'm moving depth. So E as well. Then again I'm backtracking. Then again I'm backtracking. Okay. I am moving to G. I am moving to G. Again I'm moving to F. I'm moving to F. Okay. I'm moving to F. Are we clear? Yes. So I'm going in the depth. In the BFS, what I have done, I'm going level wise. I'm going level wise. But here I'm going straight forward to the depth. Straight forward to the depth. Okay. So this is how the DFS will be. Okay. So in DFS, if you wanted to do the implementation, what you can do, you need not to, you will have your visited array. You will have your visited array to check if it is visited already. Okay. You will have your visited Boolean array, and you will have the visited Boolean array, and you will have the, like, you don't need anything. Only you need adjacency list. Okay, you need adjacency list, as well as you need the visited array. Okay, now what you will do, you will just, if you can see, depth, I'm backtracking again. I'm going forward, then I am backtracking again. How we can solve this? Can I go with recursion? Can I go with recursion? Yes. So I will go with recursion. So what I will do first, I will go with the A. I will go with the A. For A, I will make it as true. For A, I will make it as true. And then I will go here. I will call the B. By following the adjacency list, I will follow the B. I will call the recursive of B. Suppose this is function DFS of A. Okay, DFS of A. And I will use the adjacency list. I will make this as true, A as true, B as true. So let me explain this 1, 2, 3, 4, 5. Okay, give me one moment. Explain this. Like a small graph, if I take, you will understand. I will also clear your doubt, Anurag. Give me one moment. Okay, I am taking visited array. Okay, visited array 1, 2, 3, 4, and then 5. Okay, 1, 2, 3, 4, and 5. I'm making this as everything as false. Okay, initially it will be false. Okay, so 1 I am visiting. So what I will do, I'll make it as true. Okay, and in adjacency list for 1, what is there? 2 is there, 4 is there. Okay, 2 is there, 4 is there. I will move to 2. I will choose 2. You can choose anything. So what I will do, DFS of 1 I am calling initially, then I am calling DFS of 2 as well. DFS of 2 as well. And 2, I will make it as true here again. I'll make it as true here again. And then DFS of 2. DFS of 2 is 1 also, but 1 is already visited. 1 is already visited. So I will not go to 1. I will not go to 1. I will go to 3. I will go to 3. Again DFS of 3. Again DFS of 3. Okay. DFS of 3. And then for 3, what is there? 5 is there, 4 is there. Both are not visited. Both are not visited. So I will again go to the 4. Suppose if I'm going to 4, DFS of 4 I will call. Okay, I'll move to the 4. I'll make this as true. I'll make this as true. So for 4, what is there? For 4, what is there? 1 is there, 4, 5 is there. 1 is already visited because it is already true. Whereas 5 is there. So I'll make this as true. I'll move forward. I will move forward. DFS of 5. Okay. Then I will move to 5. I will move to 5. For 5, what is there? 3 is there. 4 is there. For 4 is there. Then if everything is done until n we have come. Until n we have come. Then what I will do? I will just return. I will just backtrack. While backtracking, I will add it to the array. I will add it to your answer array. Okay. I will add it to the answer array. Okay, I will return that answer array basically. I will return that answer array. So 5, 4, 5, 3, 2, 1 like that. I will return the answer array. Okay. So this is how we'll be doing. Let me go to the code. So cyclic graph, you have asked Anurag. So this is how we'll do. We'll track, we'll not, if it is, this is a cyclic graph only, right? This is a cyclic graph only. But we are not traversing more than once because we are using the visited array. Because we are using the visited array. Okay, since we are using the visited array, we are not traversing more than once. Are we clear? Yes. So fastly, I will. What doubt? This is only your doubt, right? Okay, I'll move to the code fastly. The same thing again in the main method. You'll be adding edge. You'll be adding edge, and you will call the DFS of with adjacency list. Okay, with adjacency list, you will call the DFS. And if you see the DFS here, if you see the DFS here, where is DFS? Okay, you see, I'm taking a visited array. I'm taking array list for your result. Okay, then what I am doing, I'm calling the, I'm running from 0 to until the adjacency size. Okay, what is the size? It is 6, right? It is 6. So I will go to 0 to 5. I will go until 0 to 5. If it is not visited, if it is not visited, then what I am doing, I'm calling this again. I'm calling the DFS rec. Okay, I'm calling this DFS function. Okay, I'm calling this DFS function. Then what I'm doing, I'm making that visited array, that particular element, what is visited as true, and then I'm adding it to the result. And then what I'm doing, if it is still not visited, then what I'm doing, again, I'm calling the DFS of rec. Again, I'm calling the with adjacency list, visited array as well as I and as well as result. I'm passing it to the array. I'm calling it recursively. I'm calling it recursively, and again it will come here. It will make that particular element what is there as true. Okay, it will keep on 1, 2, 3, 4, 5, 6. It will keep on going at that particular point, and it will do that. Okay, we are calling it recursively. Just you are calling it recursively. Okay, just you are calling it recursively. Are we clear? Yes. Are we clear? Yes, everyone. Okay. So okay, I'll be taking 5 more minutes and I will explain the DP intuition, and then we will continue the assessment. Okay, 5 more minutes, only 5 more minutes. I will continue. I will go with the okay. I will go with the dynamic programming. Okay, so we are not any left with dynamic programming. So basically, dynamic programming is not a new concept. Okay, it is not a new concept, but it is based on again your recursion itself. It is based on again your recursion itself. Along with you will use some adjacency matrix. Okay, otherwise you will use some adjacency list. Okay, adjacency list and solve the problem. Okay, adjacency list and you will solve the problem. So either you will use recursion as well as adjacency matrix or adjacency list, and you can solve the problem. So basically, dynamic programming will be based on will be more comfortable for these kind of problems like longest or smallest. If you wanted to find smallest subsequence length, or if you wanted to find minimum edit operations or max edit operations to form a string. Okay, mostly string problems. Okay, and if you wanted to get like optimal solution, basically optimal solution based problems. Okay, to find the optimal solution based problem, we'll use this algorithm, that is dynamic programming. Okay, so if you wanted to smallest greatest number, so the for all those things like subsequence sub problems, subsequence based problems, we'll use this dynamic programming. Okay, so in dynamic programming we'll be using two techniques. Okay, we'll be using two techniques. We'll be using two techniques, that is either tabulation we'll use using adjacency matrix. Okay, otherwise we will go with the memoization as well. Okay, memoization as well. Okay, either we'll use tabulation, otherwise we'll go with the memoization as well. Okay, so basically in dynamic programming, we are dividing a problem. Suppose there is some cat cab is there. Okay, in this you need to check which character we can swap. You can edit, minimum edits you need to do, and you need to make them as equal, make them as equal. So what is the one edit you will do? You will just swap either of this edit you will do, right? Then this will be equal, this will be equal. So what you will do for this in dynamic programming, we will divide this into sub problems. First we'll take this, we'll compare, it is true, we'll take this answer, and we'll also compare this, we'll take this sub problem, we'll take both CA, and we'll check, and then we'll check this. Here we will have the character as different. So in that case, what we will do, we will swap this up. So what we will do in this, we are dividing it into sub problems. We are dividing each and every letter into sub problems, and then we are using that sub problem result. Okay, we are using each and every sub problem to to calculate the main problem, calculate the main problem answer. Mostly dynamic programming, if you want the result in numbers, you can go with the dynamic programming algorithm. Okay, are we clear until this point? Yes, everyone. Okay, so I am going with this problem. Longest common subsequence. longest common subsequence. So this problem is like this. So A, B, C, D, E, A, C, E. Okay. So basically what this problem is telling, suppose A, B, C, D, E. Okay. Subsequence in the sense you can, AB is one subsequence, right? BC is some subsequence. AD also can be subsequence. It can't be continuous. Contiguous. The continuous is not required here. That is not a constant here. So AD is also considered as one subsequence. AE is also one considered as subsequence. ADE is also one considered as subsequence. Okay. So again, so what is this problem telling is I'm taking the ACE as well. I will take okay. I will take a long string. Okay, AED. Suppose NEK. Okay, AED. Okay, I'm taking this. So now you see, if you can see, so what is the longest substring length? So what are the common here? A is common, A is common, okay, A is common, and E is common, E is common, and then E is again here also common, and then D is common, right? A, D, E are common. But if you see A, D, E, here also, if you consider this A, E, and D, it will be of two length only. It will be of two length itself. So we don't want this. We don't want this. So what you will do? It should be of longest length. Longest length. So A, D, and E. So what will happen? We will take this only. A, D, and E. So the length is three letters, right? So it will be 3 itself. The answer will be 3 itself. Okay, the answer will be 3 itself because there are like 3 letters. Those are common. Okay, we need to find out this. We need to find out this. So what is the common sequence? That is common, the longest length. Okay, the longest length which is common, you need to find out this. Okay, so here it is 3 itself. Okay, so what you are doing here to solve this problem, what I can do, I will go with the tabulation approach. Tabulation approach. So I will take n plus 1 matrix. Okay, so let me draw that matrix faster. Okay, how many letters are there? 1, 2, 3, 4, 5, right? I will draw a 6 by 6 matrix. 1, 2, 3, 4, 1, 2, 3, 4, 5, and then 6. Okay, here also 1, 2, 3, 4, 5, 6. Okay, 4, 5, and then 6. So here you will be taking a letters, right? You will be taking a letters. So I need to draw 1, 2, 3, 4, 5 only, right? Written 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. So E, AED, NE. Okay, AED, NE, and then ABC, ABC, D. Okay, this I should not write. AEDNE. Okay. So initially the first row and first column I'll be taking as 0 itself. I'll be taking as 0 itself because suppose if any of the string this is null, this is not given, only this part is given, then in that case you should return 0 only, right? There is no common, so you'll return 0 only. So for that reason you'll be taking first row and first column as 0 itself. And then if suppose you are taking this, okay, you are taking, okay, you are taking this, okay, you are taking this ed is one substring, right? Ed is one substring, right? Ed is one substring. You are taking this, and then suppose here ed, and then de. This is also one, de also one substring, da also one substring. Like this, you will think, you will see. AA is one, AE is one substring, AD is one substring. You'll make it up all as one, like that. Okay. So now you see, like you'll traverse the diagonally. You'll traverse diagonally when the character matches. When the character matches, okay, when the character matches, diagonally you will check. Okay, you will check diagonally when the character matches. If this is x, this should be x plus 1. Okay, this should be x plus 1. And then if suppose the character is not matching diagonally, then what you will do, suppose here you see, here it is like here you see the character is not matching, it is n, it is d, the character is not matching here diagonally. So what you will do, what are the neighbors? If suppose a is there, here b is there, of this which is max, you will put this up here. Okay, which is max, you will put it up when the character is not matching for that. So let's do this quickly. Let's do this quickly. It is not going. Okay, I will fill this table, and then we will continue the assessment. Okay, so a is one ab is one substring. Okay, here a is nothing. Okay, a is nothing is there, so I'll make it as 0. Then ae a is one substring, right? A is one substring, I'll make it as 1. I'll make it as 1. Okay, I'll make it as 1. A is one substring, I'll make it as 1. And AD is one substring, I'll make it as 1. AN is not a substring, but here you see, it is 1 and 0, which is max, 1 is max. I'll take it as 1 itself. Okay. Here also you see AE is again the substring. So I'll make it as 1 itself. Okay. So like this, I will keep on iterating. Okay. I will keep on iterating. So EA is another substring. EA is another substring. EA is another substring. Then E is not a substring, but I will take the max of this one. Okay. ED is one substring. Okay, ed is one substring. And if you can see, the character is matching here, ae. So what I will do, I will take it as 2. Okay, when it is character is matching, I will take it as 2. And here also de, it is not matching up, so I will take it as 2 itself. And then here also cat is not matching, so I will take it as 2 itself. Okay, then here you see, so like this I will continue. Okay, like this I will continue. So if you can see e and e, so I will keep on iterating over it. Okay, I will keep on iterating over it. So it will be 2, it will also be 2. Okay, then here also it will be 2, it will be 2. And if you can see, here it is the character is again matching, here only to become it's 3. Okay, so here you see the character is matching. So like this I will go on iterating, I will go on with the top length, I will go on with the top what is there on the top length. Okay, so what I will do, I will share this code in the notes. Okay, you please dry run it and let me know if there are any issues. Okay, so on that note, I will wind up the session here. So with this concept, the like my teaching part is completed. Okay, so we'll continue with the tests now.
Yeah, thank you, sir. Thank you so much.
So thank you so much, guys, and please do well in the test. Okay, those are until what is covered, until what we have covered, until trees and graphs. DP I have not touched it up. Until trees and graphs, what is covered from linear to non-linear data structure, I have made it up. So all the best for your assessment. Do well. Okay. So on that note, thank you so much. Have a happy Christmas and happy New Year. All the best for your future as well. Yeah. Thank you, guys. Over to you.
Yeah, thank you so much, sir. We really appreciate your all 15 days of classes. I hope this has got helpful for our students. Thank you so much once again. We'll meet again in the next SDP or FTP for definitely, sir. Thank you so much.
Thank you, Sushmita.
So yes, dear students, I'm just sharing the assessment link on a chat. Okay, and the attendance link I'll be sharing for today. I'll be sharing at 9 p.m. After your assessment. So I request till that please don't ask for the attendance link. So right now I'm sharing the assessment link on a chat. Kindly start taking assessment as we have just 30 minutes left. So the assessment will be for 30 questions and 30 marks. So yeah, you can kindly read out the questions carefully and start taking it. Let me share the link first. Yes, the assessment link is on our chat, both YouTube and Zoom. I request please click on the link and start taking assessment. And as I told, please don't ask for the attendance link. Okay. So attendance link I'll be sharing after this completion of this assessment. So at 9 o'clock I'll be sharing, and even about the certificate, I'll inform you all after the assessment. So yeah, now start taking it. Kindly read out the questions carefully and take assessment. 5 more minutes, students. I request please complete the assessment as soon as possible. At exactly at 8:55, the link will close. So please complete the assessment. Okay, those who have completed the assessment, just drop a message in chat that you are done so that I can assume you all completed the assessment. Kindly drop a message in a chat that you all completed the, if you have completed, kindly message me in a chat. Okay, I'm getting so many responses. Thank you for responding, students. Okay, now in 1 minute, the assessment link will be off. I mean, it will not work. So I request please submit the assessment as soon as possible. Okay, fine. Thank you all for submitting your assessment and replying me on chat. Yes, about the attendance, I'll be sharing it right now. Okay, so you all can mark your attendance. Yes, attendance link is share it on a chat. Kindly mark your attendance. Okay, so yeah, I'll let you know all about the certificates and all. So the certificate, as you all know, if you are attending our previous SDP sessions, you all know like the certificate we will be issuing for your register mail ID. So we require at least 10 working days, 10 to 15 working days to issue the certificate. So I request please be waited for 10 to 15 days. Within that only you will all get the certificate. And you all know the criteria. If you secured above 60% of attendance, then only you will get the certificate. If you don't secure 60% of attendance, you will not get the certificate. You have to secure above 60% of attendance. Okay. And all this 15 days of recordings and materials is already uploaded in LMS dashboard. You can go through, you can access the LMS, you can go through the videos, or you can go through the materials which has been used on the classroom. So all the materials will be visible. I hope you all understood about the certificate. If you secured above 60% of attendance, then only you will all get the certificate. I request to be wait for 2 to 3 days. I mean, sorry, 10 to 15 days to issue the certificate. Within 10 to 15 days, you will all get the certificate. Okay. Any other questions? I will wait for 5 more minutes. If any questions, kindly drop it in a chat. I'll just check and answer for all those. Any questions related to LMS or something, or any questions related to certificate or anything, you can just ask me. Not the technical, just the apart technical, you can ask me the questions. Assessment link exactly at 8:55 it has been closed. Before that, it is not closed. It was exactly at 8:55. The assessment link has been closed. Where can I get a notes? Yeah, as I informed, the notes materials which is already uploaded in LMS dashboard, you can go through there. And one person is asking how to access the LMS. See, if you have not got the LMS access, you have to get the LMS access, then only you can access. So I request please drop a mail to edl@xlr.com. So our team will connect with you, or they will issue your query. I'm just dropping a mail ID on chat. If any concern or if any issues you're facing, I request please drop a mail to edl@xlr.com. edl@xlr.com. Anurag, as if now we have not scheduled the program, the upcoming programs. So we'll definitely connect with you all. For if any upcoming programs are there, we'll let you know. So assessment marks, we will not show anything because the assessment is just for your knowledge purpose. It will not validate for your a certificate or something. It is just for the knowledge purpose we have conducted the assessment. Okay, any other questions, guys? Okay, while sharing the assessment, at the starting only, I have informed that 8:55 that then assessment link will be closed. So yeah, if required, if for your knowledge, if you're required, I'll no issues. I will active the assessment link. You can take it out, but this assessment won't be like considered for the certificate. I did not get the LMS credential as I told. If you have not get the LMS credential, I request please drop a mail to edl@xlr.com so that we can take your mail ID and we can give a LMS access. Ma'am, will XLR free certificate hold any value as a fresher in interviews? Yes, definitely. The knowledge which you have gained, it is not based on something, right? The certificate which you will get the topic, so for definitely it will get value for your resume or for your fresher or a job role. Assessment score is already visible in the Google form itself now. Yeah, after you are submitted you can view your marks scores. Yeah. Okay, any other concern or any other questions, students? When will I get the certificate? As I informed, I request be to be waited for 10 to 15 days. Within 10 to 15 days, you will all get the certificate if you are eligible. The criteria is, as you all know, the criteria is just 60%. Once you like, you have to secure above 60% of attendance, then only you will get the certificate. Yes, definitely the certificate will have some value on your resume. Okay. I hope you all marked your attendance. I request if you have not marked the attendance, kindly mark your attendance. I'm just sharing the attendance link once again on the chat. If you don't have any questions to be asked, you can drop the session. I'll wait for 2 more minutes. If any other questions, you can ask. You can't download the certificate. The certificate we are giving, like we are sending to your mail ID. For your registered mail ID, we will be sharing the certificate. You cannot download the certificate. Ma'am, sometime I can't fill the attendance, so I get the certificate or not. As I told, if it is above 60%, if you have got the attendance, then only you will get the certificate, or else you will not get it. Yes, Prathamesh, the notes or materials which is uploaded in LMS, you can go through there. Ma'am, can you share Roshit's LinkedIn ID? No, sorry, we can't share any of the personal details of trainers. So no, we are not supposed to share the something LinkedIn ID or mail ID or something. Okay, I hope I answered for all the questions. Okay, repeatedly you guys are asking about the certificate. As I told, you can't download the certificate. We will share the certificate if you are eligible. If you secured above 60% of attendance, we will share the certificate for your register mail ID. Okay. As please be waited for 10 to 15 days. You will all get. Okay. Okay. Yes. Thank you all. Thank you so much for joining uh, for our SDP program. We'll definitely meet again on next SDPs or FDPs. Thank you, everyone. Thank you for joining, and all the best for your features. I hope this 15 days of class has been helpful. So I request, please, if any doubts, or if you want to know about the topics, please go through the videos, study the materials, for definitely you will get it. And yeah, a very all the best for your future and also education. Thank you, everyone. Good night. Thank you all.